So what we're going to be covering today is a lot of different aspects about RIA security. There's a number of plugins which are coming into the market. There's a number of new technologies being introduced by plugin vendors, by the HTML5 spec. And what we're going to cover is how you can take a look at those threats and understand those threats without necessarily being an expert in each individual plugin. So we're going to walk through those. We're also going to talk about how those interact. Might seem a little bit weird for Flash Player and Silverlight to come together and do a presentation with each other, since we do have overlapping technologies. But we do have the same security goal. We all want to try and maintain the same origin policy. We all want to make it easy for webmasters to host our content, know that they can do it securely. And with attackers looking at developing cross-technology attacks, it becomes more important for vendors to talk to each other and to try and identify areas where someone might try to mix our technologies together in order to create a complete attack, where each one of our security models may be fine on its own and within our own particular context, but attackers aren't going to limit themselves to just using one technology. They're going to look at looking multiple technologies. And by coming together, it also gives us an increased view of the threat landscape and make sure that we, since the web security model isn't necessarily defined and the same origin policy isn't hardly written, that at least if we're talking together and we're sharing ideas, then we can ensure that we're both sort of heading in the same direction with where the web should be. So when we're talking about RIA, we're going to be talking about mostly plugin technologies. We're not going to transfer into the desktop technologies of talking about things like Air or Silverlight when it's applied as a desktop application. We're going to focus mostly on plugins that extend the capabilities of the web browser to be able to provide an improved user experience, stream video, more user interaction. So we'll talk about JavaFX, we'll talk about Flash, we'll talk about Silverlight, but we're not going to necessarily talk about the individual desktop technologies that are sort of hybrid models. Very quickly, I'm going to go through a couple of concepts around domains and same origin policy. I imagine most of the people in this audience already know them, so I'm going to go through this rather quickly. But there are a couple key points that are going to be important to our presentation as we move forward. So I just want to make sure I touch on those and help refresh everyone's memory. Basically, same origin policy says that if domain A loads domain B in an iframe, then domain A can't reach into domain B. Everything from one domain is put into a bucket, everything from another domain is put into a bucket, and those aren't allowed to cross and talk to each other. But when you're talking about the same origin policy with plugins, you have to understand what domain does the plugin belong to. And the answer to that question in both of our cases is the domain of the Swift or the domain of the Silverlight ZAP file is the site on which it is hosted. It is not the site which is linking it in from the HTML page. So you can think of them as iframes. When you have an object tag and you specify the source as a remote destination, whatever's in that source tag that points to that ZAP file or points to the Swift, that's going to be the domain. So if you look at like this example, if this was HTML on example.org, the top HTML links to a Swift, the bottom HTML links to a Silverlight ZAP file. The Swift, as far as the Swift is concerned, when it's making its security decisions about what domain it is, believes it's on adobe.com, and the ZAP file would believe it's on microsoft.com. Neither of them would consider themselves to be a part of example.org. And when we do our domain comparisons, we do full domain matching. So web1 is not example.org, isn't the same as web2.example.org. We pay attention to ports. We pay attention to protocols. There are a couple of exceptions there in the web model where you can actually abstract things up to super domains. And ports aren't always recognized in certain situations. Sometimes when you're talking about cross-domain security, it's truly the domain. It's not the domain in the port. But for the most part, these rules apply. So the first thing I want to get into, where we start to actually move into the new stuff that's not a recap, is talk about cross-domain technologies. And the web's been advancing, especially within HTML5, to introduce more cross-domain technologies. JavaFX has the ability to do cross-domain communication. Silverlight has that capability. Flash has that capability, as well as HTML5. And all of these technologies have slightly different permissions. So when we talk about them, what we're going to want to be able to do is actually have a more formalized structure about referencing them, because there are different types of permissions. There's cross-domain sending permissions, where data is just sent, but the response is not returned. You're not able to read it back. There's cross-domain read permissions. So if you think of the traditional Flash cross-domain.xml policy setup or the Silverlight client access policy, those tend to be read permissions, where you can go to another site and read the data, the response back from that site. And there's cross-domain execution permissions. So each of these have different security impacts, and people need to be aware of which one of those are. As far as cross-domain sending, the traditional method is to do a cross-domain post or a cross-domain get. The web got a little impatient with having some cross-domain technology, so some people started to do improvised different tricks, such as using document.location and setting that to the superdomain in order to allow cross-domain AJAX, or embedding JavaScript within return JSON data and evaluating on that to do cross-domain permissions. But the problem is with those technologies, they're hard to audit for, they're hard to catch, and so the web wanted to advance, and they wanted to be able to say, let's create formalized structures, because if we give them the right way to do it, then we can migrate off of these sort of improvised ways of doing it if we give them a formal structure. So one of the new things that's been developed is post message in XDM, which allows cross-frame communication. And the idea behind post message in XDM is if you have a web page and it has an iframe in it or a subframe, you can send messages to that subframe even though it's in a different domain. And you specify, use JavaScript and tags within the frame in order to be able to set that up. And those are sending permissions. With read permissions, traditionally when you would send a cross-domain post or get, you could send the data, you could go ahead and do the post, but you couldn't receive the response that came back, because the same origin policy said the response that comes back from that domain belongs to that domain. You're not a part of that domain, so you don't actually get to see the response. You can send it, but it's a blind send. It's sort of like UDP. You just broadcast it, and maybe it got there, maybe it didn't. But with cross-domain permissions, like cross-domain.xml and client access policy, you can actually send data across domain and read that response body back. Now, when you get that data back, it's just raw data. Nothing gets executed, nothing gets interpreted, unless the developer goes out of their way to do that. And in the JavaScript world, in the AJAX world, they set up similar permissions with XDR and XHR2, excuse me, where with JavaScript you can do cross-domain AJAX calls and be able to read the response body back even though it's coming from a different subdomain. And then you have cross-domain execute permissions. So with Flash you have these object type parameters called allow script access, and with Silverlight you have enable HTML access. And what these two parameters do is they allow the SWIFT or the ZAP file to communicate with the DOM of the web page. With Flash, by default, the SWIFT and the HTML can only communicate if they're within the same domain, but you can set allow script access to equal to always, which would allow the SWIFT content to be able to reach into the DOM of the web page and interact directly with the JavaScript and execute commands within the DOM of the web page. So these are not traditionally thought of as cross-domain permissions, but they are cross-domain permissions, and you're allowed to execute commands within the other domain. Other people, like I said earlier, sometimes they set window.location to the superdomain, and so rather than having the domain of the web page be www.example.org, they'll set it to example.org, and then that allows them to interact with other subdomains on example.org. But this is not really a formalized method. It's not supported across all browsers. And it's not a very refined way of being able to specify that control. And for these read permissions, they're all unidirectional, so a piece of content from domain A can reach into domain B if domain B allows that through a cross-domain policy file, but the converse is not true unless the other domain sets it up. So all cross-domain permissions tend to be unidirectional. So now that we have these new technologies, there are actually new risks that come with them. So traditionally when people have thought about cross-domain risks, they've talked about wildcards, and they said setting star in your cross-domain policy file can be bad because you're allowing any content on the web to be able to read responses from your site. It's a allow everyone permission. And it can create problems when it's on internal networks or used when they're not needed or not scoped properly. So they're not always evil. There are certain use cases where you do actually want to specify star in the cross-domain policy file, but they tend to be very limited, and people tend to misapply it because the rules around being able to do that are so specific that people overlook things. For instance, you wouldn't want to set this on a site that has login that you have to log into. You wouldn't want to set it for an entire domain. You would probably only want to set it for a subdirectory within your domain. But there are certain cases where maybe you're posting the NASDAQ results for the day. And the NASDAQ results are all public results. Everyone's allowed to read it. So if you're at NASDAQ, you might post up an XML file with the closing stock prices of the day. And you do really intend to share that XML data with the rest of the world so that finance websites can pull in that XML and do neat graphs when you go to the finance websites and track your stocks. In that case, they may want to intentionally share all that data with the world, but you just need to be careful about when you apply it. And sometimes people will go, okay, well, I won't do a full wildcard. They'll do a subdomain. They'll do star.mybestfriend.org. And I'll just trust everything that's on that particular domain, and then I'm not doing a full wildcard. The problem with that is that you have to really know what that other site's doing. For instance, Jeremiah Grossman developed this attack against Google where YouTube provided cross-domain permissions to their site to star.google.com because Google had bought YouTube, and so Google was a trusted partner, so they put star.google.com. The problem was that there were certain subdomains within Google where you could upload content. And so what Jeremiah Grossman figured out was he could send himself an email with an attachment to gmail.google.com. I don't have these domains exactly right, but for the purposes of this presentation, I'm sort of rounding them off. And that would get his attachment on a subdomain of Google. So now he had that attachment on the subdomain of Google. If he could get a victim who was a YouTube user to visit his website, and he sourced in that Swift from google.com, now he's got content that he's running and that he controls that runs under the context of google.com. And you'll remember earlier I had said that the domain of the Swift is the domain of where it's hosted, not who's loading it in. So even though the web page is evil-hacker.org, since that attachment was hosted on google.com, the Swift still considers itself to be google.com. And since YouTube has allow access from star.google.com, that Swift was now able to reach into YouTube and make requests and see the response data that came back. And then, of course, once it was able to collect that data, they could send it back to the hacker who started it. And so what he did is he was able to go through and collect what your username was on YouTube by doing requests to the web pages through cross-site request forgery, see what your favorite videos are with YouTube that was associated with your account. And so it was just sort of an example that wildcards, even when specified to subdomains, could be a risk if one of those subdomains allowed user-uploaded content, because then the content's executing within that domain. And when you get those response bodies back, you may not, those response bodies may contain sensitive information. Like, for instance, in the Flash world, we don't allow access to the headers of the response. We just allow access to the response body. And people sometimes have the misconception that, oh, well, then they don't have access to the cookies. But they never really look at the architecture of their site and realize that things like JSession IDs sometimes get echoed back in URLs within the page. And then, even though they didn't have access to the JSession ID as a cookie, they get access to the JSession ID when it gets reflected back as a GET parameter on the URL. So these are things that you really have to think about when you're allowing cross-domain access. But moving forward, sort of looking ahead to the future attacks, now that we have these multiple cross-domain permissioning systems, it's possible for there to be the idea of transitive cross-domain permissions. And that means if Site A has access to Site B and Site B has access to Site C, then it may be possible that Site A has access to Site C. And if you're a business partner, let's say you're Site A, and you're providing those cross-domain permissions to Site B, you may not be realizing that they are also providing other cross-domain permissions to their site. And so it becomes difficult for someone to get a holistic view of how much they're exposing on the web. So when people provide cross-domain permissions, they really need to think about how they're deploying them. And I actually do have some sample attacks here, that one of which actually occurred in the wild just recently. So one of the attacks that's been talked about, and I know Jesse's written about it on MSDN, is the ability to create or mix cross-site scripting with cross-site request forgery. I'm not really good with coming up with attack names, so I just sort of mixed stuff together and threw jacking at the end of it.
I like it. Works for me.
Works for you? Okay. So let's say you have the objective of stealing user data from sensitive.org. But sensitive.org knows they're a sensitive site. They've done a lot of hardening. You're not finding any good vulnerabilities on their website. But you know that sensitive.org provides XHR2 cross-domain permissions to another website. So they have one other person that they trust to be able to read their data. Well, what you could do is if you can find a cross-site scripting vulnerability on the site that they share cross-domain permissions with, on victim.org, then you're able to leverage that permission to get into sensitive.org, because you cross-site script into victim.org, you're now executing under victim.org's context, security context, and from there you can go ahead and you can reach in to sensitive.org, leveraging the cross-domain permissions that have been granted to that domain. So this might be good, for instance, for phishing attacks where maybe going after bankofamerica.com is too obvious, but maybe you can link to some other website and cross your way in there. Another attack that occurred in the wild was mixing Flash content with AJAX cross-domain permissions, where the attacker had the objective of stealing data from a website, and sensitive, that website had good security, but again they had AJAX permissions set up. So with Swift content, what you might be able to do is, if you have an allow script access permission of always, then the Swift can reach into the DOM of that hosting HTML page and execute under the context of example.org. And this actually can occur in more places than you think. For instance, it's very common to provide allow script access equals always permissions on ad networks, because that allows to provide more interactive ads where maybe the Swift is floating over the web page and following you whenever you scroll, or if you've seen the peel down ads where there's like a little tear that's flipped over in the top right-hand corner. If you mouse over it, the page peels back to show you the ad behind it. Typically, a lot of those type of ads tend to have allow script access equals always permissions. And occasionally, it happens that the ad networks aren't able to screen all the malicious Swifts out of the ad networks. And we've seen in the past where, while they're able to screen out a vast majority of them, every so often one slips through under the radar and gets through. So from that perspective, you can use the Swift to jump across domains into that DOM, and then use the AJAX permission to go out to the web page. So just to give you a real-life example of that, there's a social networking site called RenRen, and it's a Chinese website which is similar to Facebook. It's for Chinese students and allows them to share videos and information with each other. It's a social networking site. And I'll just go directly into the example here. What the attackers found is that when you shared a video on the RenRen site, that shared video, that YouTube video, would be provided with an allow script access equals always permission. So what they would do is they start by sending a victim a message saying, hey, go watch this Pink Floyd video. And the Pink Floyd video was run by a Swift that was hosted on evil.org website. And RenRen, when they linked to that video on that evil.org website, was mistakenly saying allow script access equal to always. By default, on Flash content, allow script access is set to the same domain, but in this case, they were changing the default to set it to always when linking to video content. So what the Swift would do is it would play a Pink Floyd video to keep the user occupied long enough for the attack to run. and it would inject a script tag into the HTML, where they would source in the malicious JavaScript they needed to propagate the worm. From there, they were somewhat stuck because the actual subdomain they were on, and again, I'm faking the subdomains here, the actual subdomain they were on didn't have access to all the information they needed to propagate the worm. They needed your friends list, and the friends list was over on a different subdomain, and they needed a token in order to be able to send the message. And that token you would get from an API on a different subdomain. So just because they got into one subdomain, they still need to go and get information from other subdomains to actually propagate this worm. And fortunately for the attackers, RenRen had an AJAX proxy set up where all of those subdomains were linked. So what they were able to do is they were able to leverage that AJAX permissioning system to get the read access into the other subdomains, to get the friends list that they needed from the friends API, to get the token they needed from the token issuing system, and that allowed them to propagate the worm. And so sometimes with sometimes with cross-domain permissions, you need to be careful because website developers will go and they'll separate their content on a bunch of different subdomains. And they'll go, okay, my content's protected because I've separated it out in different subdomains, and the same origin policy says that different subdomains can't talk to each other. But if you're designing your website and then you go back and you add a bunch of cross-domain links, then essentially what you've effectively done is you've rejoined all those subdomains again. So you may actually be undermining some of what you intended to do by separating things out onto different subdomains by using cross-domain permissions to link them all back together again. So it's something to think about when you're architecting your website, and you want to be very specific about how you provide those cross-domain permissions. And if you look at the specs for the different cross-domain permissions, the different technologies all provide a level of granularity. In Flash content, you can be as specific. You can provide cross-domain permissions all the way down to a specific directory on your website. With some of the the new AJAX XHR2, you can do it on a per-page basis. So you want to, when you're picking your cross-domain choices and how you're going to link things together, you want to always be as specific as possible when linking these sites together. In RenRen's case, they were using the document.location trick, and that's essentially this equivalent to doing star.google.com or star.youtube.com. So. And you need to be careful of not getting lulled into certain ideas, because as soon as I'm able to get into the DOM of the web page that has the cross-domain permission, when I send a request, the referrer for my request is going to come from that domain. It's not going to, in the examples I've shown, if it's evil.org, that's not actually going to show up as a request from evil.org, because evil.org is now operating under the security context of that victim site. So if you're relying on something like refer in order to make sure that the requests all come from the correct website as a cross-site request forgery protection, that's not necessarily going to help you in these situations. So it's something you need to be careful of and watch out for. And I think as we move together to more of a mashup world and with widgets and gadgets, people are going to be linking these domains more and more frequently, and developers need to make sure that they focus on using specific controls, that they use the formal controls, not use the older, less formal controls, and take into consideration what they're doing. So with that, I'm now going to pass over to Jesse, and Jesse's going to talk about some of the shared risks that are among plugins, so that if you're a webmaster who's got a website that has all these mashups and you've got all these different plugins, what are the common things you need to know that apply to all plugins in the event that you're not a security expert on each individual technology?
Thanks, boss.
There you go.
Got it? All right, thanks. So once again, I'm Jesse. I'm on the Silverlight team. In the picture Pella showed earlier, I was the blue Halo guy, so you know. So yeah, as he mentioned, we're going to talk a little bit about what the shared risks are here. So and kind of the way I've been thinking about this is that as more and more technologies get turned on in the web, the more important it's going to be to focus on the things that are common to all those technologies. And as Pella's mentioned, the same origin policy is a huge part of that. And a lot of what we're going to talk about here is going to be basically common to all these different technologies. I also want to point out that the RenRen worm and the other Yeah, so the Ren one that Pellis pointed out, there's nothing specifically Flash about that. It wasn't a Flash platform issue. The problem was the way the DOM access was granted to that RIA, right? The same thing could have happened with Silverlight, and I believe probably with Java as well. Just want to point that out. So the first thing I want everyone to keep in mind who's planning to develop RIAs or is doing it right now is that there are really no secrets here. It's really not that much different from HTML and JavaScript where everything's in plain text. A lot of people don't realize this at first because the applications that get delivered to the client are all kind of zipped and jumbly, and it's not really obvious what they are. But under the covers, they're really not that complicated. So for Silverlight specifically, it's really just a zip file with managed DLLs inside of it. So if someone wants to see what's in there, they can easily unzip it. They can easily run .NET Reflector on all those DLLs. So what does this mean? Well, you probably shouldn't embed secrets, keys, passwords, other things like that. Just treat it as plain text. These can be decompiled. Don't hide anything in there that you don't want people to see. There are different kinds of obfuscation tools that you could run on these things. You can use them if you want. Just know that you're setting up speed bumps. You're not adding locks, right? You're really just making it a little harder to get at the data. But essentially, you'd be playing a cat and mouse game. And if it's data you really need to keep secret, you should assume that someone's eventually going to find out about that. A great example Pellis showed me. This is a video. I think it's on hp.com. You can search for it and find it pretty easily. This is Billy Hoffman, security researcher. He noticed one day that I guess a local restaurant in his area had kind of an online game promotional thing they were doing. And the way this game works is that you play the game and you accumulate a certain number of points throughout the game. And depending on how well you do, you get sort of a free prize at this restaurant. You might get a cheeseburger or fries or whatever it might be. So, hacker that he was, he sat down and he thought he might be able to get some free food out of it. So he started looking at the data traveling on the wire as he played this game, and he realized that no data was really coming out of the app until the game was over, and then some kind of encrypted payload was going to the server. And he tried replaying the payload a little bit. It didn't seem to really do much good, but so then he thought, well, why don't we just kind of decompile this thing and see what's going on? And once he did that, it was very clear that they were just sort of hashing username with date with the prize that the player won. So once he found that out, it was pretty easy to just write his own app and spoof that request back to the server. And he did this a bunch of times, and he got a bunch of cheeseburgers. So there's that. And he did tell the restaurant about it when he was full, we're told. That's how the story goes anyway. Okay, so let's talk a little bit about loading dynamic content. And this gets a little, I'm going to be a little vague on purpose because this can mean different things depending on the RIA. So let's just talk a little bit about this. Most client-side technologies allow for some loading of dynamic stuff. In the web world, this is basically loading different kinds of HTML, CSS, JavaScript. You can load stuff on the fly if you want to. This is kind of, imagine the AJAX stuff, right? You grab some HTML content from the server that you need to display in some way. And as we all know, that kind of introduced some JavaScript injection, cross-site scripting problems on the web. So the key thing to remember here is that make sure the content you're loading, that you know whether or not you should trust it and that you're treating it the right way. Another thing to think about here is that loading content from another domain can also be another form of cross-domain communication, like Pellis was mentioning earlier. So that's something to keep in mind as well. So specifically, in a Flash, a Flash app can load another Swift inside of it. And by default, things are kind of locked down, but there's certainly controls there to open that up, and you need to be careful about that. In Silverlight, an app can load XAML or DLLs dynamically. You want to be careful when you do that. I think this really just comes down to knowing the threat model, though. You should have your DFD. You should know where your data is coming from, know what APIs they're flowing to, and make sure you look up the documentation for those APIs and see if they're really meant to be designed to handle untrusted data. So now I wanted to talk about a few kind of specific scenarios that people have asked me about, and I think might be good to go into because it'll help us kind of frame some discussion here. So the first scenario I want to talk about is just the idea of sort of allowing different kinds of content on your site. Suppose, here's your scenario. I have a web page. I need to host various kinds of content, maybe different kinds of widgets that I don't maybe know what they are, ads that come from the ad network that I'm not really quite sure what they are either. Maybe this is all using Java, Flash, Silverlight, various number of different kinds of RIA technologies. So the question is, I don't want to learn about all these different plugins. Like, it would take a lot of time to go sort of learn everything I need to know about this stuff. So what do I need to know just to make sure these components are kind of isolated and safe from each other? And the good news here is that the same origin policy applies. So if all these different widgets are hosted on different domains, then by default, everything is kind of isolated. And this is kind of the iframe model, right? This is the model web developers generally expect. If I have a page and I have iframes to a whole bunch of different domains, they're by default isolated, right? They can't talk back and forth between that frame boundary. So the nice thing about RIA plugins is that we tend to follow this model by default. Well, not even tend to, we do follow this model by default. Due to the point that if you find a way that we don't follow that model by default, that's when you send mail to secure@microsoft.com, right? Like that's something that's important, and it's Pellis and my job to kind of make sure that we make sure it holds true as much as possible. So that's kind of where we start, and if you can do that, great. But it's not always so simple. I think Pellis's example of the ad that needs to fly across the screen, which is getting more and more common, it seems like, by the way. To do that, you need some level of DOM access. You can't really just be this little island of Flash or Silverlight that is kind of in the nice little rectangle that can't break out. So that gets a little tricky. So specifically, we need to think about plugins that have DOM access switched on, or plugins that have access to your domain via some kind of cross-domain policy file. Those are kind of the key two. And then we can start thinking about kind of these other channels of communication. So as we mentioned, HTTP access. Flash, Silverlight, and Java all support some level of sockets. And this is controlled through some kind of policy file as well. So that's another thing to keep in mind. Another kind of lesser known, I think, technology both present in Silverlight and Flash is the ability for plugins to talk to each other via this kind of a shared memory mechanism. And that can be a nice channel for ads because they don't have to necessarily go through the DOM. So a lot of times if you have like one ad at the top and another banner ad, they're able to kind of communicate between themselves without having DOM access. So that's actually kind of one nice way you can solve some of these problems without having to turn on the DOM. But that's another point of communication as well. It is domain scope by default as well. If you're noticing a theme here, yeah. Like the domain is kind of the is important here. And a lot of these things are domain scope. Cookies, of course, most of us know that that's important to keep those safe. DOM access we talked about. Another thing to think about is, can the application navigate the top level page? We've seen some kind of malicious ads that kind of get into ad networks by mistake, and if they can sort of automatically navigate the top level page to malware.com or some other bad site, that can be a problem. Or suppose, here's another scenario. What if you have a RIA where maybe you have a specific RIA. You're not just plugging in an ad network. Maybe you have some Swift or Zap sitting around that maybe you lost the source code for. Maybe you don't know. Maybe some partner's helping you develop it, and you don't know exactly what it does. Maybe you need to. Maybe some users. Maybe there's some kind of way for users to extend the web experience, right? The nice thing about the fact that they're easier to compile is that makes them kind of more scannable as well. And this is something there is some tooling support for on the web if you go out and look for this kind of thing. But I just called out a few examples of things you can do. I think a lot of times what you'd want to do here is look and see specifically what APIs the plugin is calling. But there is sort of, and I have Silverlight specific examples here, but there are some kind of gotchas in terms of dynamic things that can happen. So what if you need like a page with secured access or something? What if you had some kind of banking site or some other thing where the data was sensitive and you need to make sure you're really protected against man in the middle? So we've all browsed to a site that's SSL encrypted. We got the nice lock icon, but maybe suddenly the little warning pops up about mixed content, right? Oh, some of the stuff on the page is not encrypted. What do you want to do? You want to look at the page? I think we all just click yes, right? And usually this is benign enough. Usually it's like images or something. They're kind of expensive to serve up over HTTPS, so it might just be hitting some HTTP server somewhere. But if you're loading a RIA app that way, that's not too cool, right? The man in the middle can easily replace that file. If that RIA has DOM access, then the bad man in the middle basically owns your page. So that's one important thing to keep in mind as well if you're using SSL. So another thing to think about here is it's not just about the plugin attacking the page when we talk about these cross-domain DOM threats. But there's also the possibility of the page actually attacking the RIA. So if you're writing a RIA app, when you're calling out to the page, make sure that you're doing so in a way that making sure you don't trust that data too much. Or if you do, set up some kind of way to make sure you're being loaded in the right environment. Sometimes we call that site locking, to make sure this app should only be loaded on this site. Let's verify that before we do anything else. And if you don't, if you're taking information for the page and just making important decisions based on that, there's potentially a trust boundary there, and you need to keep that in mind. Cool. So the other scenario I want to talk about is allowing arbitrary user uploads to your site. So the scenario here is, imagine I'm running some site where I want my users to be able to upload files to my server. Sounds nice. It sounds very cloudy. I have some web apps on that domain too to help do stuff, whatever. And I don't really want to have separate domains. It's kind of a hassle. Can I allow users to upload files to the same domain without risking my web apps? Well, as Pellis mentioned earlier, all these technologies do have special access to the sites and the domains from which they were loaded. So if I'm able to get my evil Zap or Swift or Jar or whatever onto your website, that means I can make requests back to that domain pretty easily. I can just load that Zap from evil.com and have special access back to your domain. So that's kind of a problem. Best practice for this scenario in general is, if at all possible, you should really be hosting this stuff on a different top-level domain that doesn't get mixed in with your other web app logic. Yeah, if you're really paranoid, even make it a different top-level domain. There's been some bugs in the past where even subdomains haven't been quite enough. So one cool attack here that I believe is attributed to Billy Rios, which he called the GIFAR attack, is in this scenario. So imagine I'm running a server where I want to allow users to upload arbitrary images, right? Not that far-fetched. It's kind of imagine Flickr, right? So Billy found a way to construct a file that's a valid GIF, but also a valid jar, which is a Java applet. And here's kind of a high-level view of how this works. GIF, is based on data kind of from the beginning, and I believe that the jar archive, I believe the way that works is that the index is actually at the end of the file. So he's able to actually make this kind of cool GIFAR file that if you upload to a domain, and if the domain runs checks on it, it will say, oh, this is a valid GIF, this is fine to put on my domain. But in fact, they're kind of opening up these cross-domain privileges they didn't realize. So that's pretty cool. This has been fixed. So I just wanted to point out that there's kind of an interesting hypothetical corollary here for Silverlight. As I mentioned, Silverlight is a zip file. So is a Word document. The docx is. So I believe error files are zips, PK, and then blah. So I haven't done this, but it should be fairly easy to construct a file that's a valid Silverlight app, that's a valid Word document, and a valid error application.
That's right.
Okay. Anyways, so if I'm trying to allow if I'm some kind of SharePoint-y thing and I just want to allow arbitrary docx's to be uploaded to my site, That's kind of a problem. It can be a valid docx, but also these other things. We do have some mitigations for this. It's something we kind of thought about when we were considering these threats. So there's just kind of a few things I called out there. But and it really comes down to kind of making sure you have your MIME type set correctly. But it's something to keep in mind if you need to do something in this scenario. Cool. Still have some time left, so I want to talk about, a lot of times us security guys focus on the negatives. And, and this slide is a little more sort of more asking questions and more forward-looking than any sort of real thing that I know for sure. But I thought there's some kind of interesting points to talk about here when it comes to RIA and sort of the developments here, and maybe what are some signs of progress here security-wise. So one concept I think about a lot is the idea of security defects that are due to the mixing of code and data. I think I first read about this in writing secure code. I'm sure that's probably not where it came from. I'm sure the idea predates that for a while. But it's always kind of struck with me, and I find people don't talk about it a whole lot. But yeah, if you think about buffer overruns, for example, a big part of the reason buffer overruns are so much of a problem is that we had the stack that was a mixture of basically jump pointers and data. And what that meant was it was very easy to make sort of these cookie cutter buffer overflow exploits where, hey, I overflow this buffer and now I control this pointer. If the pointers were stored in a completely different place than the data, then buffer overflow still wouldn't be great, but it would be a lot trickier to have kind of these cookie cutter exploits, right? It would more be a matter of, well, I can affect this data by overflowing this buffer, and maybe by controlling this data I can control this other thing. But but it makes buffer overflows like much less of a cookie cutter problem. XSS is the same kind of thing. I mean, what we're really talking about there is JavaScript injection, and the idea that I just want to display. All I want to do is display something on my HTML page, right? But the fact that some attacker, is able to get JavaScript in there, like I don't want to run any code, right? I just want to display HTML. Why are those so intermingled? SQL injection, same kind of thing. So I had to call it JSON just because this, it's kind of by design. This is how it works, right? Here's some data. Just execute this string and you'll have the data. Trust me. So I did want to point out there are some advances in this area that it's not quite as bad as all that, and there's things that people are doing to help the situation. But the nice thing about RIA is that these are more separate by default. With HTML, HTML is kind of a document model, right? I fetch a document and it contains script, and the script runs, the document is viewable, and that's great. And that's kind of where that code and data commingling comes in. With the RIA model, it's more like, okay, I fetch the app, and it's going to go make various SOAP, REST requests, etc. And the data is kind of nice and separate from the code. There's not that clear pathway. Another thing I want to talk about a little bit is just kind of some of the higher level abstractions that are happening kind of alongside all this RIA stuff. There's a lot of kind of these different frameworks that are coming out that I think the jury's still out on exactly what the world's going to look like once these get adopted or how well they get adopted. But for example, I know there's a lot of stuff going on in the authentication authorization space. This whole claims-based security thing sounds interesting. Microsoft has this thing called Geneva that we're working on. OpenID is another kind of idea like this where it's like, okay, I don't want to really handle this authentication stuff by myself. I'm going to use sort of these other providers, and we're able to rely on people who know what they're doing, and not everyone has to go write their own authentication mechanisms. So I think this was like an every ASP.NET book from like 10 years ago, right? Correct me if I'm wrong. But the way the web was then, it was just kind of almost insecure by default. It was like developers were encouraged to write bad code like this almost. Along with the RIA stuff is also coming, and this isn't just RIA specific, right? But the idea that you can kind of sit on your left hand and write a CRUD app, that makes it kind of hard for SQL injection problems to get in, right? I'm hoping that devs, especially the more entry-level types, who just need to get some basic data flow to their database up and going, like there's kind of a clearer path to be more successful security-wise here. And these are, as I said, this is mostly just kind of thinking out loud. There are some kind of dangers with these abstractions. One thing, particularly with Silverlight, is the fact that since Silverlight supports C#, which is cool, it encouraged a lot of ASP.NET developers to sort of write client-side C# as well, which is great, but there is kind of the chance that we might blur some of the lines between client and server in some cases. And as I talked about before, like you have to realize there's, it's easier to store secrets on the server than on the client. Also, abstractions can be leaky. There may be stuff going on under the hood that you're not, don't know exactly what's going on there. That could cause problems. Another problem here is as we add more components that people depend on, the updating model becomes important. I think a lot of us have the ATL issue fresh in our minds. I'm sure a lot of people in this room, did a lot of the work to help clean that up. And unfortunately, the updating story is often kind of an afterthought for these kinds of things. So I'm curious to see how that develops. Cool. So just had a few quick conclusions. DOM access, very important. When you switch on the DOM, make sure you know what you're doing. Make sure you know who you trust. Pellis covered a lot of the different kinds of cross-domain permissions and how they can work together. Make sure you understand where your sensitive content is and tailor your cross-domain permissions around that. Remember that everything here is plain text, no secrets, and if you have a site where you're allowing user uploads, make sure you're aware of what that means when they're hosted on your domain. So I think that's about what we had. Do we have some questions? Or do you want? Oh yeah, I got some references. And these are just kind of pointers to our security documentation for Flash and Silverlight respectively.